My name is Paolo Piccardo. I'm Associate Professor in Metallurgy at the University of Genoa. I'm a Professor at the University of Bordeaux and Associate Researcher at the National Council of the Scientific Research in Italy. My main interests are in renewable energies and new materials. In the frame of my research fields, I often feel the need to test materials in specific kind of conditions, like temperature or atmospheres. Thanks to the cooperation with the Ergo design in Genoa, we designed and manufactured the test bench called Real Life Tester. The Real Life Tester is able to test many kinds of materials in temperatures higher than 900 degrees and in atmospheres of any kind, even multiple atmospheres at the same time. During the test, which can last more than 1,000 hours, it is possible to gather electrochemical measurements in real time. 3 years ago, we started to use the real-life tester in the frame of a European project devoted to high-temperature fuel cells, the so-called solid oxide fuel cells. In this frame, we tested all kinds of materials, like stainless steel used as interconnects, the glass used as sealant, and the fuel cells themselves. The possibility to use high temperature, we reached in that specific case 800 degrees, and dual atmosphere, hydrogen and nitrogen on one side, air on the other side, under a constant current load, allowed us to achieve measurements on the performances of the cell and all the materials for a long-lasting time. The longest test reached 1,000 hours. The results, excellent, were comparable, perfectly comparable with the real-life test applied on the stacks of SOFC. It means that with this test bench, it is possible to measure real-life materials in real-life conditions, and that's the reason for its name, real-life tester. All along the aging test, electrochemical impedance spectroscopy have been measured in various conditions, and this allowed us to reach the goal to evaluate the modification and alteration of the materials under operation. This has been checked afterwards using the same kind of samples in the post-experiment conditions in the scanning electron microscope or other kind of spectroscopical and analytical devices. For example, in our specific case with interconnects, it was possible to estimate the formation of new phases and the formation and the specific quality of the thermal grown oxide on the surface of the stainless steel. One of the main characteristics of the real-life tester is its flexibility. This makes it suitable for many fields in material science. Together, we can customize the real-life tester to match your research needs.